Our next lesson is F.D.A. 2. It's going to be on advanced factor dimensional analysis. And in this, we're going to look at two things. We're going to look at solving problems by combining units, and then solving problems by splitting units. So let's take a look at what we have here. So sometimes equivalent expressions do not appear to have the same dimensions, which is normally a problem. Because as we said before, excuse me, that the units have to match up on both sides. Is that if you get a result that is not in the same dimensions, the same types of units that you would expect it to be, then it's simply wrong. And so we have a case like this. So we say that 14.5 acre minutes per meter equals some value beta foot seconds. And so normally we'd say, okay, let's look at things here. An acre is an area, a minute is a time, a meter is a distance. Over here we have a foot, which is a distance, and second, which is a time. And so for this one right here, this doesn't look like this works, because acres or area times time per distance would not be the same as distance times time. The distances are on the wrong side. There's one on the bottom, there's one on the top. The times match up, and there's no area whatsoever that's over on the right. But let's take a little more close look at this. Acres. It's an area. An area is another way of saying a distance squared. Now we have distance squared times time over distance. And if you have distance squared over distance, what happens is that the squared is going to cancel with this distance. And so as a result, you're just left over here with distance times time, which is exactly the same set of units, the same dimensions as our distance times time on the other side. And so one option that we have here is combining units, is that in certain cases where we have units that are basically raised to powers, sometimes hidden raised to powers, like an area is actually a distance squared, or a volume is a distance cubed, or a volume squared would be distance to the sixth, something like that, where we can actually reduce the units, we can combine the units, and then be able to show that they're the same units on one side as the other. And if that's true, that they are the same dimensions on both sides, then we can then solve the problem. And the way that we'll do that is basically by getting the uncombined units, so in this case that would be the ones we're going to cancel, are going to be acres and meters here, getting acres into some unit of some distance squared, and getting meters into that same unit of distance. So we could say, let's take acres and convert it into, well, meters. So acres and convert it to meters squared. And if you had acres into meters squared, it would cancel. Or you could say we're going to take acres and convert it into inches squared, and then convert meters into inches. Then it would cancel. In this case right here, since we're looking for an answer in feet, it probably would make most sense to convert acres into feet squared, convert meters into feet, let them cancel out. At that point, you just got feet left over, and then take minutes into seconds. So let's try this one out, see what we get when we work this out. So we start off with 14.5. Our units are acres, minutes per meter. And so let's work this out. Let's go ahead and keep going with this. And this is going to take at least a couple spots through here. So let's get acres first. We said we wanted to get acres into feet squared. That way we could cancel it with what the meters once we get that to feet. So we're going to get rid of acres first. And how are we going to get from acres into feet squared? Well, a quick look at our sheet for our Common English Units of Measure sheet says that we can convert acres to square miles, then square miles into square feet. So that would work. And so we know that there are 640 acres in 1 square mile. So 640 acres in 1 mile squared. Once we've got that, we want to get rid of miles squared and go to feet squared. And so 1 mile squared is 5,280. It's an 8. Squared, feet squared, and 1 squared mile squared. That gets us to feet squared. And so at this point right here, we have gone ahead and canceled out acres. We've gone ahead and canceled out miles squared. We have feet squared here. Can't do anything with the feet squared for right now. We're going to have to go ahead and get meters over, and so we'll do our little double line to show that we're going to convert the next one over. And let's go ahead with that meters. So we want to get rid of meters. We want to get from meters to feet. So what we can do is we can go from meters to centimeters, centimeters to inches, inches to feet. would be the best way of doing this. And so meters to centimeters first. And I'm going to go ahead and just say 1 meter is 100 centimeters. You can, once again, do, if you wanted to, 10 to the negative second meters is 1 centimeter. Both of those will work fine, dot, dot, dot. And so we're going to continue this down here, going across. And so we have centimeters on the bottom. We already canceled out meters. We have centimeters on the bottom. We want to get rid of it. So we have centimeters on top. We want to go to inches. We know that there are 2.54 centimeters in 1 inch. Now, so we continue with that. So we've got that to inches here. We want to get rid of inches. We want to go to feet. And so there are 12 inches in 1 foot. So and that ends that section. So let's go ahead and let's cancel what we can cancel. So meters has canceled here. Centimeters cancels with centimeters on top. Inches with inches on top here. All right. Now, currently, if you look at our units, we have minutes right over here times feet squared right over here divided by feet right there. So feet squared and feet will cancel because I can take feet, cancel off feet, canceled off the squared on this one. So now I have minutes times feet. And so I want to get feet per second, so my feet are good. Now I just want to get from minutes to seconds, and so that means I can just continue my conversion here. Minutes is on top, so to cancel it, I got to put minutes on bottom. And I want to go to seconds. That's fortunately an easy one, 60 seconds in 1 minute. This point right here, I have canceled minutes. My units right now are simply feet times seconds, and so I can get my final answer just by multiplying this out. And so I would say 14.5 times 1 times 5,280 squared times 1 times 2.54 times 12 times 60 divided by, on bottom, 640 divided by 1 divided by 100. 640 second, just 640 divided by 1 divided by 100, then divided by just ones from there on out. So in this case right here, that I end up getting, let's see, what is that? That's 11,551,066. Our significant figures here, 14.5, 3 sig figs. So we'd have 11.6 times 10 to the, what did I say? I said 11 million, so that would be 10 to the 7th, I believe. I'm doing that in my head right. So times 10 to the 7th foot seconds, and that's going to be equal to our variable, which is beta, right up here. And then so our final answer, beta, is equal to 11.6 times 10 to the 7 foot seconds. So this gives us an example. Even though it looks like at first this will not match up, we cannot get this to work, we can by combining the units. Let's look at a slightly different version of this. Same technique, but you have a different type of problem. Not really a unit conversion in this case, but just a case like this. Show that E equals mc squared, Einstein's famous equation, is not dimensionally inconsistent, because it looks like at first it might be. E is energy. Energy is measured in joules. Equals m is mass. Mass is measured in kilograms in our MKS system, in SI. C is the speed of light squared. Speed would be in units of meters per second squared. Is it the case that a joule is equal to kilograms times meters per second squared? That really doesn't initially look like that would make sense. But let's take a look and see what we've got here. Is that in the case of this right here, let's write off what's on the right side and write a little bit differently. So let's distribute everything out. So I have kilograms out here times meters squared, because I got the squared right up there, divided by seconds squared, because I just writing this square on to make it meter squared and second squared there. Now kilograms times meter squared per second squared. Now, what's the definition of a joule? Well, remember we said before that a joule is a derived unit. It's written only in terms of our other units. Now, if you look up what a joule is, you may have written down before, or if you look online right now, you'll see that a joule is quite simply defined as being a kilogram meter squared per second squared. Are those equal? They are. And so in this case, very simple way of doing this, that by combining these units together, over here on the right side, we're able to show that it's exactly the same as our definition of a joule before. And so that's the reason why this equation works. You would sort of wonder, why is it that multiplying something's mass times the speed of light squared would give you an energy? It does because of the way the units work. That's the definition of a joule. And it turns out that this equation does make sense in terms of the units, even though at first it may not look like it does. So let's look at sort of the opposite side of this. If we could combine units before, that means theoretically it also might be useful to split them occasionally. Now this usually gives people a little more trouble for some strange reason, but let's try it out. So 8 liters is equal to delta meters to the fifth per township. Most people would not expect that a liter is equivalent to a meter to the fifth divided by township, or at least the same type of units, but let's find out. A liter is a volume. Meters to the fifth is distance to the fifth power. Township is an area. So is volume equal to distance to the fifth over area? Well, once again, let's take a look. Volume is distance cubed. Distance fifth is distance to the fifth. Area is distance squared. And so if we were to take distance to the fifth divided by distance squared, we'd get distance cubed, which is exactly what we're looking for here. And so these units do match up, and so we're good on that. Now we've got to figure out a way to get this to work. What your basically process is going to be here is that we start off with liters. We first want to get that liters into some unit of distance to some power. In this case right here, maybe meters, maybe centimeters. Centimeters is actually what I'm probably going to use here because it's sort of an intermediate. It's easy to go between centimeters and a lot of other things because we can convert from centimeters straight to inches. So we'll probably go to centimeters first. If I can get liters into centimeters cubed, I could rewrite centimeters cubed as being basically exactly the same thing as centimeters to the fifth over centimeters squared. And if those two things are equal, then that basically means that I can go from centimeters to the fifth to meters to the fifth, and I can go from centimeters squared to townships. And that's going to be the path that we're going to take here. And so let's start off with 8 liters in our table. Going across here. We want to cancel liters first, and we said we want to go to centimeters cubed. And so we can go from liters to milliliters, then milliliters to centimeters cubed. And so liters to milliliters, and I'm going to say 1,000 milliliters in 1 liter. Once again, you could use 10 to the third 10 to the negative third liters in 1 milliliter. That's just fine. Now we've got milliliters. We want to go from milliliters to centimeters cubed. Okay? And we know there's 1 milliliter and 1 centimeter cubed. Now, here's sort of where the magic happens. So let's take a look at what we've canceled so far. Liters is gone. Milliliters is gone. We just have centimeters cubed. What we could do is we can say here, centimeters cubed. I can sort of, for all intents and purposes, and I'm going to use a double line here just to show how this works. Whoops, double line, not like that. That's not what I meant to do. Okay, so centimeters cubed here is that one way of writing out centimeters cubed is that this is no different than writing out centimeters to the fifth over centimeters squared. If I cancel out the centimeters cubed right here. These things are equivalent. I can do a substitution. Another way of doing it would be to cancel this out and write these both on top. But note that when I do this little trick right here, by writing out the centimeters to the fifth over centimeters squared, I have not changed the value of anything. Reason why is because 1 centimeter cubed is equal to 1 centimeter to the fifth divided by 1 centimeter squared. Those two values are exactly the same. I'm free to do that. But by being free to do that, by canceling this one out right over here and then rewriting them down here, is that now it lets me do the rest of my conversion. And so let's take a look at this centimeters to the fifth that's on top. And so I want to go from centimeters to the fifth to meters to the fifth. That's what the question asks for. And so I have centimeters to the fifth on bottom, meters to the fifth on top. And so how many centimeters are in a meter? There are 100 centimeters, but since it's the fifth, it'd be 100 to the fifth power centimeters in 1 meter to the fifth. That's what I've got right there. And so now, cancel centimeters to the fifth. I have meters to the fifth. Now I simply have to finish the rest of this. And so once again, dot, dot, dot. We're going to start it down the next side. Dot, dot, dot. Continuing here is that I have now centimeters squared on bottom. I want to get rid of centimeters squared. So that goes on top. But how do I get from centimeter squared to township? I can go from townships I have a conversion from townships to square miles. So what I could do is I could go from centimeters squared to inches squared to feet squared to miles squared to townships. So I think that's what I'm going to do here. So centimeters squared on bottom means it has to cancel centimeters squared on top. So I have inches squared down on the bottom, so 2.54 squared, centimeters squared and inch squared. Then I want to go from inches to feet, inches squared to feet squared. Got to pay attention to your powers on these things, which means I have 12 squared inches squared to 1 foot squared. So that gets me to feet squared on bottom. I then want to get rid of feet squared here to miles squared. And so that would be 5,280 squared, because I can't fit that in there, feet squared in 1 mile squared. And that gets me to miles squared. And so I've got miles squared on top, townships. Township on bottom here. And a quick look at your common English units of measure tells you that there are 36 square miles in 1 township. Note we didn't have to square the 36 because it's 36 square miles in 1 township. Let's make sure our units cancel. We had centimeters squared on the bottom. That cancels with centimeters squared up here. Then inches squared to inches squared, feet squared, miles squared to miles squared. Our final units here are meters to the 5th over townships, which is what we want, meters to the 5th over townships. So this should work out as long as we just multiply things out properly. So doing so, we have on top 8 times 1,000 times 1 times 1 times 1 times 2.54 squared times 12 squared, which is 144, times 5,280 squared times 36. All that divided by, on bottom, 1 divided by 1 divided by 1 divided by 100 to the 5th power divided by 1 divided by 1 divided by 1 divided by 1, which gives us the final answer of 745,916. Now, significant figure-wise, this is all multiplication. Our original value was 8, and that's only one significant figure, so our answer will have one significant figure, and so it would be 800,000. And so in this case right here, is that our final answer here is going to be 800,000 meters to the 5th per township. Not a very normally useful unit, but sometimes these things can be useful. Sometimes you will have something that doesn't seem like it would make sense in a particular set of units, but does when you look at it overall. Let's take a look at one that actually probably doesn't really make a whole lot of sense, but it's sort of interesting to think about. Gas mileage. Normally you measure a car's gas mileage in miles per gallon, but I'm going to say my car's gas mileage is 6.022 times 10 to the 10th inverse acres. You sort of wonder, how exactly would you measure gas mileage of a car in inverse acres? Well, let's take a look. We want to figure out what this is in miles per gallon. And so inverse acres, if you were to write this out, let's get this up here, is 1 over area. We want to get this to miles per gallon. Miles is a distance per gallon, which is a volume. And so does this work? Well, area is distance squared, sorry. So I have 1 over distance squared over here. Well, that's 2 right there. Volume is distance cubed. And distance divided by distance cubed, that would cancel this distance out. That would cancel one of these two out and make it squared. So I have 1 over distance squared and 1 over distance squared. These two should work. Doesn't seem like they would, but they do. And so you can describe your car's gas mileage in inverse acres. That would be a completely legitimate way of writing it, even if it doesn't normally make a whole lot of sense. So let's take a look and see how we might work this out. So we start off with 6.022 times 10 to the 10th, and just for reference, it just happened by chance to turn out to be 6.022. That's the same as Avogadro's number as the coefficient here. No, it's not the same power. So it's not that my car has some sort of magical Avogadro gas mileage or something. It just turned out this way whenever I worked out the problem originally. So 6.022 times 10 to the 10th, inverse acres. And so when I write this out, I'm actually not going to put a unit on the top. I'm just going to put acres on the bottom, like this. I could have put another unit on top, but there's really no reason to do that. I could just 1, but this is fine. So we want to get from acres into miles per gallon. And so the first step is we have to get from this acres into a distance squared. And so in this case right here is that acres actually goes into square miles. So let's start off with just getting this into square miles. And so we want to cancel out acres. We want to go to miles squared. And so there are 640 acres in 1 square mile. That's its definition. And so once we've got that, is that we're now in miles squared. And so looking at our cancellation, we've canceled acres here. We want to convert this from miles squared on bottom, 1 over miles squared, into distance over distance cubed. Because distance over distance cubed is the same as 1 over distance squared. And so we want to get this from miles squared into miles per miles cubed. And so we can once again do our little double line. And by canceling out miles squared, we can then go to miles per miles cubed, just like that. So these things are the same. So double line again, so as we go on to our next line down here at the next side. Get that all the way across. So we're looking for miles per gallon. Well, we've already got miles on top. That's already taken care of. Now we just need to go from miles cubed down on the bottom. So we want to cancel that, miles cubed, into gallons. So how are we going to get there? Well, we can go from miles cubed to feet cubed to inches cubed to centimeters cubed to milliliters, milliliters to liters, liters to quarts, quarts to gallons. Long path, but it should work. So we got miles cubed to feet cubed. So 1 mile cubed is 5,280 cubed feet cubed. Then we want to go from feet cubed to inches cubed, which is 12 cubed inches cubed in 1 foot cube. Then we want to go from inches cubed to centimeters cubed. So it's 1 inch cubed and 2.54 cubed, 2.54 cubed centimeters cubed. Like that. Now we can go from centimeters cubed to milliliters, which is our next one here. That's just 1 right here. Dot, dot, dot. Start of a new line here. Dot, dot, dot. So we have right now, let's see, milliliters on bottom. So we want to cancel milliliters. We want to go to liters. And there are 1,000 milliliters in 1 liter. And then we want to go from liters up here to our next one, which is quarts. And there are 1.06 quarts in 1 liter. And then for our final step, go from quarts to what we're looking for, which is gallons. And there are 4 quarts in 1 gallon. So let's make sure we've canceled properly here. So we have miles cubed on bottom, miles cubed on top. So those two cancel. We have feet cubed to feet cubed, inches cubed to inches cubed, centimeters cubed, milliliters to milliliters, liters to liters, quarts to quarts. So those are all canceled. The only units we have left here are miles divided by gallons, miles per gallon. So we should have this set up right. We just need to once again work out our problem here. We have, for looking at the gas mileage, we have 4 sig figures, so 6.022, 4 sig figs, which our answer should as well because we're just multiplying here. And so let's work this out. So 6.022 times 10 to the 10th on top times 640 times 1 times 1 times 1 times 1 times 1,000 times 1 times 4 divided by what's on bottom. So divided by 1 divided by 5,280 cubed divided by 12 cubed divided by 2.54 cubed and divided by 1 divided by 1 divided by 1.06, and then this gives 34.892. So that would be 34.89 would be 4 significant figures, miles per gallon. And so I get pretty good gas mileage in my car. So 34.89 miles per gallon would be my gas mileage. Or if I just wanted to mess with people, I could say it's 6.022 times 10 to the 10th inverse acres, because those two values are the same thing. And so that's how you would go about splitting units in a case like that.